Okay, this video is going to take us through some important loop vocabulary, and so these are vocabulary words that you should begin to learn and begin to memorize, because I'm going to be using these terms, and the expectation is that you're going to know what they mean. So if you don't, then you're not going to understand what I'm saying. It'll also help you to communicate whenever you need to communicate and talk about loops. This will make it easier for you to talk about it. You can be more articulate, so to speak, regarding loops if you know the vocabulary and what it means. So we should be on your page 2 of your notes here. And so what we're going to look at is a term called definite loop. And what we just learned about today on for loops was a definite loop. A definite loop is predetermined by the programmer to iterate a certain number of times. Okay, remember, iterate means to execute the body of the loop. So it's predetermined by the programmer to execute the body of the loop a certain number of times. Okay, so anyways, so it's also called a count controlled loop or a counter controlled loop. So a definite loop that is predetermined by the programmer to be executed a certain number of times. For instance, in our loop control or in for loop example, we set this up to go 4 times. It's also called a count controlled loop or a counter controlled loop because it uses a counting variable. And we're going to talk about a counting variable versus an accumulating variable on another time. But it uses a counting variable that increments by 1 in each iteration. Now, these words, remember, these words are not foreign. If I asked you to go into a barnyard and count the number of pigs in the pig pen, you would count by ones, typically. You would start at 1, you go 1, 2, 3. You're incrementing by 1 every time you count. And so it should not be foreign and hard to understand that a counting variable increments by 1, because that's what you do when you count. And so so that's a definite loop. It's predetermined to be executed. The loop is predetermined to be executed a certain number of times. Now, the loop control variable, which we mentioned on page 1 of our notes, is a variable that controls the loop. Just by looking at the name, you should know what the loop control variable does. It's called a loop control variable because it controls the loop. It's a variable, a memory location that controls the loop. It determines how many times, or it determines whether the loop is going to be executed or not. The loop control variable is always in the Boolean expression, or you might say the condition of the loop. The loop control variable is always in the condition or the Boolean expression of the loop. And so if you notice up here, our loop control variable here, the one that controlled the loop, was the variable count. And so the count is in that Boolean expression. And so if you had a bunch of other variables in this program, so to speak, they would not necessarily be in this Boolean expression. But because count is controlling it, then it's going to be in the Boolean expression. Now here's how it controls it. Let's say I change this to a 6. Well, now when count becomes 7, it stops the loop, where before it stopped it when it became 5. So it controls the loop. So it's always in the Boolean expression. So there are 3 parts to every loop as it relates to the loop control variable. And this is whether they're definite loops or not definite loops. So the 3 parts are the loop control variable initialized. And now I already mentioned this in page 1, but we're going to put it on this page. The loop control variable initialized is got to happen first. And so up here, we have the loop control variable count is declared, but it's not initialized yet. So then it gets initialized in the first section of the for statement. So now it has a value. The second part of the loop control variable, or the second part of a loop, is when the loop control variable is tested. When it's tested, when it's part of the condition that's evaluated to be true or false. And so up in the for loop, here the loop control variable is being tested. It's part of the condition that's being evaluated to be true or false. If this Boolean expression is true, the loop is executed. If the Boolean expression is false, the loop is then, we kick out of the loop and we do not execute the loop body. The third part of every loop is the loop control variable being updated. It's got to change. And so if you remember that we had count as the loop control variable, it's got to change. So now, by the way, the loop control variable being updated is, of course, right here. This is the update. So the loop control variable initialized, tested, and updated. And so the nice thing about a for loop is it's all done in one line. All those 3 things, those 3 parts of the loop. So when count was 1, then the loop was executed. When it was 2, the loop was executed. When it was 3 and then 4, it was executed. And then when it became 5, then the loop was stopped. Now let's assume, or let's just take out the update. Now what's going to happen with that? So if the loop control variable is initialized to be 1, 1 is less than or equal to 4, it executes the loop. And then we go to the back door, only there is no back door. There is no update. So we go right here and test the loop, or test the loop control variable again. Well, 1, it's still 1. 1 is less than or equal to 4, so we execute the loop again. And then we go to the back door, but there is no back door. We go test it again, and 1, it's still 1. 1 is less than or equal to 4. So guess what kind of a loop you have when there is no update? You have an indefinite or an infinite loop. An infinite loop, it loops, it will go on forever. You'll have box 1, box 2, box 1,612,000, box 70 trillion, 700 billion, etc., etc. It's going to have, just keep on going. So no update, infinite loop. Now let's relate this to a loop that is not a definite loop. And this is something you should also write in your notes. Right here, this right here is an example of an indefinite loop. Now sorry for this is hard to write small, but this is an indefinite loop right here. This is what we worked on at the beginning. All right, it's an indefinite loop. The reason it's indefinite is because it is not predetermined to iterate a certain number of times. In fact, the programmer does not know how many times the loop will be executed. Right? And so it is an indefinite. It's just like if your coach said to go run 7 laps today. Well, that's a definite number of laps. But let's say the next day the coach says, I need you to run, for 10 minutes, get as many laps in as you can. Well, how many laps are they going to run? In other words, how many loops how many times are you going to iterate the loop? And you go, I don't know. After 10 minutes is up, then I'll know. So it's indefinite. And so that's what's happening here. And so this is also called, and you want to make sure you get this down, this is not called a count controlled or counter controlled. This is called an event controlled loop. This is an event controlled loop. And so why do we call it that? Is because it's controlled by a specific event. Well, let's look at this. First of all, before we explain this, let's put loop control variable to this particular indefinite program or indefinite loop. So we said that the loop control variable is always in the Boolean expression or the condition. So the loop control variable is either going to be balance or target. In this case, it is balance. This is the loop control variable. This is what controls the loop. So this loop is initialized on this line right here. All right, so it's initialized right here because the balance is given an initial balance of 1,000. I'll just go here. Okay, so this is balance. I'll just do BAL for a shortcut. That is, it's been initialized. The loop control variable has been initialized. All right, now we said that the loop control variable has to be tested. Well, it's tested right here. And let me see. So it's tested right here in this Boolean expression. So is 1,000 less than 2,000? And that's tested. If it's true, then the compiler then executes this loop. If it's false, then the compiler stops the loop. Okay, then we said that a loop control variable has to be updated. Well, when is the loop control variable updated here? It's right here, balance. So if you remember, so balance is the interest is being added to it. So if you remember last time when we went through this, the first time through the loop, the balance was updated from 1,000 to 1,050. And then notice the next thing that happened. It was just like here, after it's updated, it goes to the count, or it goes to the Boolean expression. Well, after this loop was done, we return to while, and we go check that Boolean expression. And so it gets tested. And so the loop control variable is 1,050 now. It's getting closer to 2000, but it's not yet. So it's true, so it continues the loop. So then I think we had something like 1100, I don't remember, 1102, and then, then it keeps getting higher and higher. It gets keeping updated. Every time through the loop, balance becomes higher and higher, larger and larger. And eventually it's going to become 2000 or more. And it's going to then stop the loop. So what is the event? Well, the event here is going to be the target or the balance. The event is going to be the balance becoming, and I can't write this very fast, so I'm just going to write part of it, is the balance becoming equal to or greater than the target, which is 2000. So that's the event. It's controlled by an event. Well, what event? As long as the balance is not greater than or equal to 2000, it keeps going. But once that event happens, when that balance actually becomes equal to or larger than the 2000, then it stops. All right? And this right here is that event that determines that the loop has to stop. All right, so make sure you have that. This is an event-controlled loop. And it's, even though it's not a definite loop, it still has it's initialized and updated and or tested and updated, and that balance will control the loop. Okay, so now we're going to go down a little bit further here. Okay, so the off by one error, well, what is that? Well, that typically refers to when the programmer makes a mistake in the coding and accidentally then either one more or one less iteration than desired occurs. Either one more or one less iteration than desired occurs. So that example would be here. Let's say we wanted to iterate this 4 times. But let's say that the programmer left out the or equals to, and this is a common problem that most of you or many of you are going to deal with. Let's say that they want this to iterate 4 times, but they start at 1 and they end at 4, and when it's less than 4, then it's only going to iterate when count is 1, when count is 2, when count is 3. But when it becomes 4, it stops the loop. So it's only executed or iterates 3 times. That's 1 less than what the programmer wanted it to do. All right, it can go the other way around. And so maybe it goes 5 times instead of 4. All right, and here, it can even happen down here. Let's say that you want to, let's say the programmer goes, oh, we're going to start up here with the year being 1. All right, that's not going to make sense. But they just may not be thinking clearly on this. And so what happens the first time through the loop, year updates, or increments, by 1, and so now year becomes 2. So on the first time through the loop, it'll give the balance. The first time it calculates that interest is going to be during what is apparently year 2. So that's not going to be right. It's supposed to be year 1. And so it will iterate. Actually, it'll get there sooner, I think, if I'm thinking about this right. This will start at 2 instead of starting at 1 right here on the first time. So it's probably going to say 16 years to double instead of 15. So it's going to be off by 1. All right. So that is the key thing for off by 1 years. It's so common that there's a name for it. All right. So let's continue on here, and let's look at how we can actually tell how many iterations a loop is going to go through. And so you can do this very easily. Some of you are going to be able to look at it and just tell right away. But what happens here is that programmers either start with an initial value of 0 or 1. And, some people think differently. And so let's say you start at 0. Well, you got to be careful. If you start at 0, and of course it's incrementing by 1 each time, if it starts at 0, it's going to go through the loop when count is 0. And then when it's 1, it goes through, and 2, 3, and 4, it goes through. On 5, it stops the loop. So how many times is this loop going to iterate if there were a loop body to it? It would go 1, 2, 3, 4, 5 times. Now, you could have done the same thing by just going 1, count at 1, and count as less than or equal to 5. Now, see, I prefer this myself because it's easy to do the math. It's not an issue. All right, but there's sometimes where starting at 0 is appropriate. And so you got to really be careful if you wanted to iterate a certain number of times. So, for example, in the example I was showing you up here, if it makes sense to start this at 0. And so there's going to be times like that. So what I need you to do is go through and count. Now I just shown you a way that you can do this, but go through and determine how many times each of these, including F, is going to be iterated, and then come back and check to see if you are correct. Okay, so you should have already calculated how many times each of these loops is going to run, and let's just see if you got it right. So for B, it's going to be 7 times because it starts at 1 and it has less than or equal to 7, like I was demonstrating before. On on C, it goes from 1. Now, if you think of this, if this up here makes sense to you, that it's easy to tell it goes 7 times, let's pretend that you have an or equal to. Then that means this is going to execute 12 times. But without the or equal to, that's going to lessen it by 1. So it's going to really be 11. That's another way to think of it. Otherwise, if you go 1, 2, 3, this may take too long to write down all these numbers. So that's one way to think of it. Okay, let's go here. Now this is going to start at 0 and go to 9. Now, here's a way to think of this. Let's say we started at 1 instead. If you go 1 and then it's less than or equal to 9, that's going to be 9 times. It's like this. This is the one that's easy. This is the kind I like the best. So it's going to be 9 times. But instead of starting at 1, you're starting at 0, which means you're going to go 1 extra time. So instead of 9, it's going to actually be 10. Now, if that doesn't make sense to you, then do the count method like I did up here. Start at 0. Okay, it's going to go through when it's 0, when it's 1, when it's 2, etc. And then count out how many times it's going to go. And you'll see it's 10. Okay, the next one is 1 to 5. Now, how are you going to do this? If you did this method over here, it's going to take a long time. So that's why looking at it like I've been trying to explain up here would make sense. So here you go. You have 1. And then if you say or equal to, well, then that's easy. It's 521 times. But you're not doing or equal to, so it's going to be 1 less than. When it gets to 521, it doesn't execute. It stops. And so then this is going to only be 520 times. All right, and then F, it starts at 0. And what you have to do is it starts at 0. it's tested here, it's less than 6, and it's incrementing by 1. So you're starting at 0 and going less than 6. And so again, if you go, let's say you go, well, let's pretend it's or equal to, well, no, let's say this is 1. Well, actually, I'm going to do, this might be too complicated, so I'm just going to do it this way. So you start, when it goes through, it will go through and count as 0, when it's 1, when it's 2, when it's 3, when it's 4, and when it's 5. When it's 6, it doesn't go through the loop. It stops it. So it goes through 1, 2, 3, 4, 5, 6 times. So this one is 6. All right, so that is it for the notes on this page, and that's all we got to do.